Hello everyone. This video will show how to evaluate a given composite trigonometric functions. Now let's go over this first example. So we're supposed to evaluate cotangent of arc cosine of 1/2. The first step that we need to do is to let this whole thing inside the parentheses equal to theta. In order to get rid of this inverse cosine that we have here, or arc cosine, we are going to cosine both sides. So this is how it's going to look like. So once we cosine both sides, we can go ahead and cross out this cosine and arc cosine. So we are left with cosine theta is equal to 1/2. Now let's determine this value 1 and 2 relative to the angle theta. We can do that by using the acronym SOHCAHTOA CAUSHATCHO. So I'm going to go ahead and write that up here. So this acronym stands for sine theta is equal to opposite over hypotenuse, cosine theta is equal to adjacent over hypotenuse, tangent theta is equal to opposite over adjacent, cotangent theta is equal to adjacent over opposite, secant is equal to hypotenuse over adjacent, and cosecant is equal to hypotenuse over opposite. So in this case right here, we have cosine of theta. So cosine is adjacent over hypotenuse. So that means 1 is the adjacent side and 2 is the hypotenuse for this theta. So we can go ahead and draw the right triangle down here. So if this is our theta right here, we can go ahead and say that adjacent to this is 1. So this will be our 1 here. And the hypotenuse here is 2. So it's going to be up here. So we can go ahead and label this triangle. Our leg A is 1. Our B is missing. And our hypotenuse C is 2. Now we can go ahead and solve for B here using the Pythagorean theorem. And the formula for the Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to go ahead and write that up here. So our a here is 1. So I'm going to plug it in. That's 1 squared plus b squared is missing. And our c is 2. I'm going to square it. So I'm going to go ahead and simplify this. So that's 1 plus b squared is equal to 4. And then we want b by itself here. So we're going to subtract 1 from both sides. And so our equation would come out. B squared is equal to 3, but we want b by itself here, so we're going to square root both sides. So if you have a square root and squared, they get crossed out. So our b is square root of 3. So we go ahead and plug that over here. So that's square root of 3. Now we remember that our a here is the adjacent side, our b is the opposite side, and our c is the hypotenuse for this triangle. So going back to the given expression that we have here, that's cotangent of arc cosine of 1/2. I'm going to go ahead and write that up here. Now we remember that at the beginning, we set this whole thing to theta. And so we go ahead and say that we're actually looking for cotangent of theta. So in this case right here, looking at the acronym that we have, cotangent is the reciprocal of tangent, so that is adjacent over opposite. So we go ahead and determine the adjacent side and the opposite side from this theta right here. So our adjacent is 1 and the opposite side is square root of 3. Now, if you notice, we have a radical in the denominator, so we're going to go ahead and rationalize this. We can do this by multiplying square root of 3 over square root of 3 to both the numerator and the denominator. So we can go ahead and say that our cotangent theta is square root of 3 over 3, because you have square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. So I go ahead and write that up here. So this is square root of 3 over 3. Now let's have another example. So in this example, we're supposed to evaluate sine of arcotangent 2 over 3. So the first step that we need to do is to let this whole thing inside the parentheses equal to theta. So I'm going to go ahead and write that down here. To get rid of this arcotangent, we are going to cotangent both sides. So this is how it's going to look like. So we can go ahead and cross out cotangent and arcotangent. So we're left with cotangent theta is equal to 2/3. Now let's determine what is this 2 and 3 relative to the theta. To do that, we're going to use the acronym SOHCAHTOA CAUSHACHO. So I'm going to go ahead and write that up here. Since we have a cotangent here, we're going to use this acronym. So that means this is adjacent over opposite. So we go ahead and draw the right triangle down here. So if this is our theta, our adjacent is 2 and our opposite is 3. And so this is our hypotenuse right there. We can go ahead and label this as our leg A, this is our leg B, and this is our hypotenuse C. Since we are missing the hypotenuse C here, we're going to use the Pythagorean theorem to solve for C. And the formula for the Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to go ahead and plug in the values here and solve for C. So c squared is equal to 13, but we wanted the c, so we're going to square root both sides. So we are left with c is equal to the square root of 13. Now looking at the triangle right here, this is our adjacent, this is our opposite, and this is our hypotenuse. So in the problem, we're supposed to evaluate sine of our cotangent of 2/3. So I'm going to go ahead and write that up here. Now please notice that this expression that we have inside the parentheses was defined as theta at the beginning that we have here. So we're pretty much looking for sine of theta. In this case right here, if we have sine, we're going to use this acronym SO, and that is sine is equal to opposite over hypotenuse. To do that, we're going to use this triangle that we have here where the theta is. Our opposite is 3 and our hypotenuse is square root of 13. Since we have a radical in the denominator, we're going to rationalize this by multiplying a giant one in a form of 13 over square root of 13 over square root of 13. So I go ahead and say that our sine theta would be, that's 3 square root of 13 over 13. So this is the value for our sine theta, or this whole thing right here. So I'm going to go ahead and write that up here. So that is how we evaluate composite trigonometric functions.